In this video, we will use a t-test to determine if the average teaching evaluation score for men and women differ in a statistically significant way. For this to happen, we first need to compute some basic descriptive statistics. We like to have the mean, the standard deviation, and the number of observations, but computing these three statistics to be computed separately for men and for women. So the way to do it is that we switch to SPSS and we click on Analyze, and under Analyze we click on Reports, and under Reports we click on Case Summaries. So if we were to do this in SPSS, we would look at this dialog box. Here we would see that we have certain options. Notice there's this option for display cases. Now this is a critical option. Why? Because we have to deselect it. So always when you're working with summarized cases, just deselect this. And then populate the dialog box. Under variables, we put teaching evaluation, and the grouping variable is female instructor, so we can compute the statistics, that is the averages for teaching evaluation based on the two groups, male and female. We may have to click on statistics. If we were to click on statistics, this particular dialog box appears. It would only show number of cases if you were to begin fresh. Then from this side, you select mean and standard deviation, bring them over this side by clicking the arrow, which would point rightwards, and then click on continue, and the results appear here. If you look at the statistics, you have the first column with female, male, and total. The number of observations total is 463, of which 195 courses were taught by female instructors and another 268 by male. The average teaching evaluation score for females is 3.9 and for males is 4.06, slightly higher, and the standard deviations are 0.53 for female and 0.55 respectively for males. So the question is the following. The teaching evaluation for females at 3.901 is slightly lower than the teaching evaluation for men or male instructors, which is 4.06. And the question is this difference statistically significant? We can answer this question using a t-test. And to do this in SPSS, we click on Analyze, Compare Means, and then on Independent Samples t-test. Let me repeat. We click on Analyze, Compare Means, and Independent Samples t-test, which brings us to this dialog box. And here we click on Teaching Evaluation from the left side, bring it here, which is our test variable, and our grouping variable is female. Now notice that when you bring female to the grouping variable box, it will show two question marks because the software doesn't know how to deal with the two groups. Then you click on Define Groups, and then there you specify 1 as female and 0 otherwise. And we know this because we know our data set. And as soon as you click on OK, that this dialog box will be updated like this. Now it would know that female is coded as 1 and 0. You click OK, and you will have your output, which would look like this. Notice that this is a fairly broader, longer output. And I would double click here in SPSS on this, and it will show up as a pivoting tray option. And I will move the numbers around such that the dependent variable and statistics are on this side and the rows, and assumptions are in the columns. So here are assumptions. We can assume equal variances or not equal variances, and there's a test for it. But this is much more legible than the alternative where the entire results are displayed like this. I think it's a question of personal taste. I prefer not this option, but a slightly reformatted option of this one. So the primary question is, what's a t-value? And under both assumptions, we get similar results. Our t-test value is minus 3.2, and the significance, the two-tailed significance, is 0.001, which is less than 0.05, which is usually the critical value. So how do you interpret this result? We have a t-value of 3.2 and significance of less than 0.05. We return to our main rule of thumb that if the absolute value of the calculated t is greater than 1.96, we reject the null. And the null hypothesis is that the difference in means is equal to 0. That is, the average teaching evaluation score for men and women is the same, and hence if they are the same, the difference would be 0. So we will draw the following conclusion, that given that the absolute value of the t-test is, which was right here, if you recall, 3.2 or 3.25 and 3.26, in both instances it's higher than the threshold of 1.96, we can reject the null and conclude that since the difference, we're rejecting the null, our conclusion is the difference in the teaching evaluations of male and female instructors is statistically significant.